So to start with, I fix the constraints. Again, it's better to keep it simple. I had set all the height constraints and everything where Stack View itself was deciding how the height has to be accommodated. So instead, I removed all the constraints and then just kept leading, trailing, top and bottom, but pointing to the content view instead of the code cell. So that was one mistake I made, but then yeah, mistakes happen. So now it's fine. So multi-line, everything is showing properly, just that you'll have to set if you are within a stack view, then just keep the basic let's say the constraints, like set it closer to the content view instead of code cell. That's what I realized right now as a mistake. So that's done. And plus a couple of things we missed out before we moving the core data towards the database side. So at least a couple of calls we have to do, begin updates and end updates. Wherever these two callbacks are happening, fetch results controller delegate. One is when the controller will change event is getting called, call the begin updates, and table view dot end updates. Also, this will make sure that the table reloading is optimum whenever there is a change happening during the beginning and end of it. It only reloads the table view, and this is more optimal way of doing it. So these two calls are needed. So with this, I guess that's pretty much is what is needed with the core data working with, let's say, within the view controller. This is what we try to do here. So now let's start with moving core data outside in a different the database layer, so that it's at least have a separation of concerns clearly defined. So I'm just gonna do a database folder and then just going to call it and create a new function called a Swift file called core data database. So this is the class I'm going to start with, and it's going to even import core data. So one of the things that we are trying to avoid in this at least in this episode is to not let view controller know about core data, but then it only knows about the basic information needed to maybe reload the table view and insert the data, show the new data and everything. So for that, let's do this. I'm just going to call this core data database. Nothing implemented yet, so I'm just going to keep it empty, but then we're going to have a protocol created. We can approach this in two ways. I'll show both of the ways. One is using protocols, other is using closures. Protocol works, at least these are two approaches. So let's start with now the protocol way right now. So I'm just going to call it as what is this called? A quotes DB. So it's a database protocol which I'm creating, and I don't need any foundation or anything being used here. So I'm just going to create a protocol called quotes DB, and it's going to have the same kind of functions that we have, like the save, which is going to accept let's say the author and the content, which we were having even at that even with the other approach where we were having this. So this is done. So basic stuff, let's start with implementing this on to this core data layer. Core data, the database which we created, which is going to at least encapsulate the core data side. So let's implement this function, and whatever we are going to do now is to move that save function over to this side. First thing first. So this is done. So Now you can see for save, the core data calls has to come here. So starting with, let's say we bring this persistence container, move it, at least not move yet, but then we bring that over here. Persistence container is brought in here. Let's also have an init. Initialize, keep it private so that it's, maybe we can make it singleton to be available for multiple maybe multiple classes or instances can accept this instance then. So there, for that same reason, I'm going to create let shared is going to be the, I'm just going to keep it the data. I'm not exposing the whole class, but instead I'm just exposing the protocol which we had created right now, and create a CoreData database instance. So this is now available for outside consumption. So that's created. Codes can be consumed through this shared instance. And now let's move the other call of save, which we had here. On add code, we had this save code function. Maybe it's a good idea now to move the whole implementation over there. Maybe one by one we will start moving. So let's have this here. So code save is here. So now save can happen within this one. So persistence container we are loading here, calling the save. So that is now available over here. So at least one bit is encapsulated now. Save code is happening here. So the other part which needs to still move is, so maybe it's a good idea now to maybe get rid of this guy. Save code is gone from here, so it's going to give me an error that it's being called here. So instead I'm going to start consuming the shared instance which we created now. Maybe I'll call it private let the database. I'm just going to say database, which is of type CodesDB. So then we are now exposing that database through a protocol now, instead of exposing it through the whole class. CoreData database dot shared instance. That's it. So I will have instance shared. Instance member shared cannot be used on type, so I need to make it static. Static let. So now it should be fine. So I have this database available now, so that wherever I was calling this, I can maybe get rid of that and make the save call directly here. Save, author, and content. So that's resolved now. So you have the save happening through the database layer right now. But then that's not enough. We have to completely move stuff outside. So let's keep working on that. Let's go back. We have this bit, the persistence container.load persistence happening, and there is a table view call happening. So maybe let's copy this one first. So this is the bit where it is loading the persistent store. So it's better that we move it within the constructor of this one, because this is going to be called once for the shared instance. I'm just going to call here, and now you're going to see it is going to ask for the fetch, perform fetch, and even the table view. Okay, this anyways, my mistake. This should be ending. Oh, okay, I made a mistake. Even persistence, whatever I did earlier, I had kept it within that persistence layer. I need to move it outside. This should be outside the table view. Pretty bad. So that's resolved, I think. Now whatever we need here is the fetch results controller has to again now move. So let's even move that. fetch results controller moves to the CoreData database side. Lazy implementation, so it can remain. Now it's saying self needs to be implemented, so whatever implementation we did over here has to now move there. So this bit you can maybe copy this. Maybe I can get rid of this because okay, maybe I'll just cut this part, move to the CoreData side, database side. Extension now should be on CoreData database, but we need to get rid of these things. There is a begin update happening and end update happening, as well as inserts happening here. So these are the things which are going to be different now. So can all declare NS object protocol. So one more thing we need to do here is to have any object implemented here, which in turn is going to ask more questions. Is it going to be any object or NS object? It should be NS object. And now there is a change even in this. We need to override. As soon as we override, we need to call super, because it needs to call its parent as well. So you're just calling super.init. So that happened because we implemented NS object over here. So that's done. So persistence store is loaded, and we have also brought in this delegate over here. So most of the things which were happening on the view controller side is removed. So we'll have to also remove this because we also moved this bit outside. So that's also moved. So persistence container load persistent store is happening when the init is happening. So that's also moved. And this delegate is no more required. Okay, this anyway we have moved, I guess. The fetch results control is also moved, so we might have to also just get rid of this part as well. So most of the dirty code is moving outside. I call it dirty because it's coupled with this, and it will become never reusable. This view controller, let's say if you had to use it at one point, you will not be able to write any kind of test cases or anything when you are coupling lots of things here. So database is available now, and even we will move these things out of view controller later, but then let's keep it here for the time being. But at least a little bit of abstraction has already happened, where we are only exposing CoreData through not even CoreData, we are just exposing the persistence layer through a protocol now. So CodesDB is that bit now. So there are things which are happening here. So CoreData is calling everything needed as soon as this is instantiated. Let's say whenever this init is used here, we have the shared instance save is also here. So as soon as that because we already have the shared instance used here, this is going to get instantiated, and the persistence container is going to load the persistent store. So we will have the perform fetch already called, just that now we need to send those callbacks now to the relevant class which is consuming, or the object which is consuming. So let's define some more stuff there. And one thing to take care is that we still have some dependencies around here. Fetch results controller.fetch objects is still used here, which we are going to get rid by using, we are going to create a model as well, so that we can send the response back through the model object instead of the CoreData object. So let's also create that new group. I'm just going to call it models, and then I'm going to add that quote model now. Because I need to call it quote model because the CoreData itself has taken that quote entity name. So I'm just calling it model, quote model. create that, and now it does not need any of this. Maybe I'm just going to say struct. It's going to be a value type, quote model, and it's going to have the same kind of parameters. Let the author string, then I'm going to have content string, and then the final thing is the timestamp, which is again going to be of type date. This is more for sorting. We can still use it, and date is coming from foundation, so I can maybe import foundation rather than UI kit or anything else. So that's done. So we have this model created. Now we also need to have inits for multiple purpose. One is the initializer using author and the content. So we'll just say self.author is author, and self.content is going to be content, plus the timestamp is going to be the current date. Maybe we can even, okay, I can just maybe do the date timestamp. As soon as it is received, the model itself is going to create that timestamp for me. And I also need another init for quote model, which is going to use the CoreData entity to instantiate something. So again, I'm going to initialize using entity, which is going to be entity, and that entity is going to be quote. So it's going to be instantiating author using the entity dot author, and content is going to be entity dot content. Finally, the timestamp, entity dot timestamp. So this is just transforming the entity to model. That's what is happening here. So in case if there are any defaults not available, I'm just keeping this. Okay, so that's my one part. So this is the one case where model gets transformed into entities. So this is what one part which is needed. So we have the quote model available now. So one thing that we can now do is to create this, and let's go back to the quotes DB, and then let's create a variable called quotes, which is going to be of type array of quote model. So again, we got rid of the direct interfacing of quote, which is the CoreData model outside. So now whichever is consuming that layer is only going to consume the codes. So something like this. So we already know this is one part where we can get rid of it already. So we already know this is going to be quotes database dot quotes. It's already available, and it's going to be array, so I can directly say count and get rid of all this code. So that's one bit of change which is happening, and then that's gotten rid of. And another change which is going to happen now is we are going to use the index path to get the code. Index path dot row, and this is going to give me the code. And the configuration which we did is also going to change, because instead of the view importing the core data, now we can just use the model itself directly. So that's another change. So yeah, nothing major changes, but then this has huge impact in the way it's going to work, because we already are decoupling lots of stuff here. So that's also done. So now it is asking for further implementation, because codes needs to understand what it needs to return. So that's the reason we need to implement even this. So let's see what it is going to return here. It's not going to be much of a difference. It's going to, again, it has to transform the entities into model. That's why we had that init create. So let's do that. Let's fetch the entities to start with. Entities is nothing but the array of code, which is the core data models, core data entities. So we just need to call fetch controller and just call fetch objects, which gives me the entities. Else I'm just going to return an empty array if there is nothing, entities are not available. Otherwise I'm going to return entities dot, I'm going to do a compact map, which is going to be the transformation. Compact map just converts one type into another type, which is more of a mapping, which we are going to do. So I know already the code model can accept an entity right now using entities. I'm just going to say $0, because this is going to loop through each and every entity. It will come through this $0 and it is going to transform my entity. So I already have the entities implemented. So codes is now available as a codes model itself and not a core data object. So that's one improvement which we have already done, and this is going to start working already. So maybe, I don't know whether it's going to crash. It's a good idea to maybe just run and see what is the impact now. It's working. So with just, this is called refactoring, just with those kind of changes, it's already started to work. It will not insert anything right now because we have not implemented those insert and update function. That's where we are going to now go. We'll go back, let's go back to the DB which we created. We had a save. Similarly, let's create some functions for begin updates and end updates. Again, we are exposing this because these functions needs to be called on the view controller side now. So insert using index path, which is going to be ns index path. So these three functions now it will ask you to implement. So let's do that. Fixed it. So we are implementing begin updates, end updates, and insert. These three are implemented on the no, sorry, these are not the implementations which we needed. Sorry, I made a mess there. What we need to do is, let's go back. These three has to come in. These are callbacks which is going, so we might have to create a delegate. So let's create another this is going to be db. So these are responses. So let's create one more protocol called codes response delegate as a protocol. So let's create that protocol. Codes response delegate. Let's include these three functions here which we copied. Begin updates, end update, and insert. These were the three things which is needed, and this is going to be a protocol which needs to be implemented. Let me also have a look. Codes, maybe we can call it codes database response. That's a better wording. data, because these are going to be responses coming out of those database. And maybe also save that, or at least change that file name as well. Similarly, response, that's it. So, and how do we use it? We have to go to the database and create a, this is my database, var delegate, and just keep this delegate, and whoever is subscribed to this delegate will start getting those callbacks. So let's implement the pending things which were missed here. Dot begin update, like just like we were calling table view dot begin updates when it was implemented in view controller, we are delegating it through a protocol now. So that way we are avoiding any kind of right now any kind of coupling, and again it's happening through a delegate, so it's easier now. So index path, everything we are delegating. So these three are already integrated. Index path. So what is the type of index path? Hopefully this is index path. That's also right. What is this type? Asking it to be index path. Okay, I think I just need to keep it as index path itself. I don't need an index. So that resolves it, I guess. Let's go back to the database, CoreData. So index path works. So we have all the three implementations set right now. Now this is not yet consumed. It is right now sending all the callbacks. So CoreData side is complete, just that for the add to work right now, we might have to make some changes, which is to implement that here. So this has to now self-subscribe. So we have the database, and in the init, or at least on the viewDit load, we need to say delegate should be self. That means now it needs to implement the delegate. So let's do that. So even before that, we need to pass that delegate which we created even to the codes DB side. So we might have to say var delegate database response, codes database response, get and set. So that way the other layer understands through the delegate that this needs to be set. So we need to set this right now, database. So let's go implement that. Table codes view controller implements this. So now we need to implement all those three functions, and we are very close to doing or making it work like however it was at the beginning, or when we finished the implementation of CoreData within view controller. So now we just need to do the same things, begin updates, table view dot end updates, and finally the insert happening here, which is again table view dot table view dot insert rows at index path. So I know the index path coming back, dot fade. So again, so it's asking one more change, database change led to what to make it mutable. So database, because we are setting it here, we need to make this as var, so that it allows it to be set over here. So that's a minor change. So otherwise things are fine. Let's run and see whether we can insert a new quote right now. So wish coming back, one more quote, new quote Let's see whether this works or not, and also let's check for multi-line working or not. In this case, it's a pretty decent one. I'm gonna add, oops, it works. So we did this bit as well. We have moved it to a layer. CoreData is outside of view controller right now. Even we can get rid of this import, and still, yeah, we still have some stuff still pending. That's the reason, but still it's going to work without any issues right now, because we got rid of all of the dependencies which were of CoreData from the view controller. So this is one way of getting rid of this. We can also do this without a protocol, but with closures. I'll also show that what changes are needed there. Maybe we can also look into that before we conclude this, and maybe we proceed with maybe how to integrate with the view model with this kind of structure. So that can also be taken up, but at least this is the basic foundation of how do you start refactoring things from, let's say, from a dirty implementation towards a cleaner, better implementation. This is one way of doing it. So I guess with that change, let's just quickly review through everything that we did. We created the core database layer right now, where all of the things needed for core data is kept right now, and the response is created, using which the other layer will, okay, one thing which is very critical is to keep it weakware, otherwise you are going to end up with obvious issue, which is again that any object that you're going to have a retain cycle if you are not keeping it weak. But still, let's keep it once more. Maybe we can run it once more and see that it's still working. Yep, it still works. So it's getting those callbacks. Maybe you'll add one more and see it's whether we are seeing those callbacks or not. Callback is working or not. Add. So that's the one bit. Otherwise you're going to have retain cycles if you don't keep the other side which is consuming it more, the delegates, to be weak. So you don't need to keep this weak if you're using a closure, which is the other way of doing it, which I will show maybe in the next episode, where we'll still progress further. But then I'm interested in also showing you the other app which I'm building, which is on location services. I just want to see how we can consume MapKit for maybe when you're on the way, if you want to really track the different location through which you are passing at a specific time, and then maybe at what speed even that you can track. And then we can even create an alert if somebody is overspeeding, and all that features. I'm maybe bringing that up using CoreData and MapKit and all integrated together. So that is one bit I'm also working parallel to this, so which I'm planning to bring in the coming episodes. So maybe before I finalize on the other approaches over here on the specific ones. But otherwise, this is what I wanted to at least show. This is all working right now. CoreData is encapsulated within its own database layer, and one best part about this implementation is that I can always bring in something like, let's say, a realm database if I want, and then it's very easy to then decouple everything. I just say realm database and then I bring that up. So that's also something fascinating with this approach, and this is more or less going to have everything related to realm, but then the outside world is going to only get exposed through this codes DB. So all of the features which needs to be there. So let's say the switch will be very simple right now. So I'm just having this implemented just to show you what is going to happen. Let's say when we go with realm. So delegate codes data response. Okay, so delegate will be this. maybe I cannot have it with an extension. It should be moved here. And then codes, let's return empty. So this is more what I'm talking about right now. So this is easily interchangeable right now. I just need to have, let's say, an init. Also, I'm just showing the stubs, but realm is not going to get implemented right away, but I'm just showing you what is the change that you will have to make, let's say. So I'm just going to say let static let database again. This is going to be static let shared realm. Okay, this is going to be the database codes db is equal to realm database dot this realm instance is created here. So compiles fine, no change. So what the change I'm going to show now is pretty good, at least beautiful, that you can directly replace this core database into realm database with no other change. So you can see it's still going to compile fine, but just that every signal that is going to come through now is going to happen through realm, but the basic structure around which every database is built is using this codes db. So we'll have to realm also will have to just accommodate these the save functions, or maybe translate the realm entities into the codes model, and even propagate back the responses through this delegate. So we have encapsulated even further using maybe another database. So this view controller is not going to know about the real implementation behind realm, but it's only knowing about the functionalities which is needed through this protocol. So that's the beauty of this implementation, that you can shuffle between any kind of database which is conforming to, let's say, codes db. So a clean architecture, at least a maintainable architecture, should be well made in this way, where every dependency has to be encapsulated and exposed through maybe a protocol or something, and response callbacks like these. So this is what I was trying to explain in this, at least. Why I picked up CoreData is not to show the power capabilities of CoreData, but at least to show that if you have an alternate database implementation like this, then even if you, let's say, want to maybe replace it to something else later, all that you will have to do is to create a corresponding implementation and then conform to a specific protocol, which let's say this view controller is adhering to right now. Like in this case, it is codes db. So that's the idea behind this tutorial, to show how easy it is to interchange between the databases. But I'll still further continue on this episode and show still more features which can be applied on it. Let's say with CoreData, how can you have an MVVM pattern implemented with basic protocols, even closures? That's something which I'm going to pick up later after this is done. So this is already done, so some more bit is still left to be done, plus along with the other tutorial which I was talking about, which is on the location services. So that's a bit of the episode I wanted to talk today. Hope you enjoyed this one. Hopefully I'll come back pretty soon with so many other new episodes. Chat application is still work in progress. Lots of stuff is still pending there, so that's the reason. Just so that I have some kind of continuity ongoing, I just picked up something to show what is possible with, let's say, CoreData or something. So until the next episode, keep subscribed, and also like this videos, share if possible, and if there are any queries, comment through the comment section, and I'll hopefully come back pretty soon with any responses I can for that. So until the next episode, it's bye from me.